Howdy folks, in calculus, today what we're going to do is we're going to talk about how to solve limits analytically. We're going to do kind of basic rational functions with polynomials in the numerator and the denominator. And what we're going to do is we're going to learn how to solve these limits by factoring or by using synthetic division. I really like the method by synthetic division. And if you don't recall how to do synthetic division, or if you do not, if you have never learned how to use synthetic division, you may want to watch one of my other videos on synthetic division. And I'll try and link one of my synthetic division videos to this video so that you can review that if you need to. But synthetic division is really easy, and because synthetic division is a special form of factoring, and so it makes solving limits very easy if they have polynomial numerators, polynomial denominators, which is very common in calculus. Okay? All right, so here's what we're going to do. We're just going to go through a few examples. Now, in every one of the cases in this video, all of these limits are going to result in 0 over 0 when you substitute the limiting x value. So when we come up with 0 over 0, that generally implies that there is a hole in the function. And so in most cases, that means that there is a limit. So when there's a hole, when you get 0 over 0, usually, but not every time, usually if you do some algebra by factoring or synthetic division, you will get a numerical answer, and there will be a limit. Okay? So let's do a very quick, simple example. This one is a classic. We'll do the limit as x approaches 4 of x squared minus 16 over x minus 4. Now, the first step in solving any limit, the first step in evaluating any kind of limit is typically to take your x approaching number and just substitute that number in for x. But if we put a 4 in here, 4 squared is 16, and 16 minus 16 is 0. And then in the denominator here, 4 in for x, 4 minus 4 is also 0, and we wind up with 0 over 0. And we don't want 0 over 0. 0 over 0 is an indeterminate form. It is not a real answer. And so that leads us to where we have to do some other kind of math, some kind of algebra, or apply some sort of rule or theorem so that we can solve this, so that we can actually get a number as an answer. You could also do it with a calculator, and that's what we did previously in the last couple days in this class, but we don't want to use a calculator on this. We want to use algebra. Okay? So, typically, basically what you do is there's 3 steps here. You basically just have 3 steps, and if you follow these 3 steps, you will always find the limit, assuming it's a reasonably simple, when I say simple, I mean it's a polynomial on the top and it's a polynomial on the bottom. The first thing you're going to do is you are going to factor the numerator, or the numerator and the denominator, or just the denominator, okay? But you're going to factor everything that you can possibly factor. And really, what you're trying to do is you're trying to take out really only one factor, and I'll talk about that in a few minutes. So step 1 is factor. Step 2 is cancel. See, there is something causing the numerator and the denominator to equal 0. And if you cancel that algebraic factor, then the numerator and the denominator won't equal 0 anymore, and you can get a real answer. So then step 3 is to plug in your x approaching number. Okay? So here's the issue, is that there is something causing the numerator to equal 0 when you plug in 4. And there is something causing the denominator to equal 0 when you plug in 4. And so by the factor theorem, and you can look that up on the internet, the factor theorem. The factor theorem very basically says that if you have a polynomial that becomes equal to 0 when you plug a number in. So let's say that let's say I have some function f of x, who cares what it is right now? But when I plug 7 into that function, the answer is 0. The factor theorem says that if this is a polynomial, assuming this is a polynomial, that polynomial must have an x minus 7 inside of it as a factor. Because when you plug 7 in, 7 minus 7 is 0. So if you were to divide out the x minus 7, you could then cancel the x minus 7 and then be able to plug your 7 in. Well, in this case, we got to take out an x minus 4, and then it won't be 0 anymore. Well, hopefully it won't be 0 anymore. Okay? So here's what we're looking at. When I plug a 4 into the numerator and when I plug a 4 into the denominator, I get 0. Therefore, there must be an x minus 4. The factor x minus 4 must be in the numerator and the denominator. Well, I can see it in the denominator. It's right there. But I can't see it in here. Now, you might be thinking, oh, come on, Mr. Ryan. That's an easy one to factor. I know that. And for now, that's fine. But if we talk about that there's an x minus 4 in this polynomial right now, then when the problems get harder, we can then continually remember that there is a factor inside of the polynomial related to this number right here. Okay? So here's what we do. We know that there's an x minus 4 in here, so we're going to factor this x squared minus 16 and reveal the x minus 4. Okay? So this is now going to become the limit as x approaches 4 of. If we factor the numerator, this is a difference of squares. X squared minus 16 is the same thing as x minus 4 times x plus 4. So we'll write that down. X minus 4 times x plus 4 over x minus 4. X minus 4. And so sure enough, look, there it is. There's the x minus 4. That's the thing that's causing the numerator to equal 0 when we plug the 4 in. So step 1, factor, we did that. Step 2, cancel. Now that we can see an x minus 4 in the numerator and the denominator, they divide each other out. They can be canceled. So we're going to cancel x minus 4 here and x minus 4 here, leaving just an x plus 4 in the numerator. And so now all we have to do is plug in. Now, just like we did at the beginning when we plugged in the 4, we can now plug the 4 in again, but we're going to plug it into what's left over. We're just going to plug it into x plus 4. And 4 plus 4, that equals 8, and that is the correct answer to this limit, is 8. Okay? All right, so this is a basic example. We're going to do some that are a little more difficult, but that's your first, the first idea is simply that you just factor the numerator or the denominator or the numerator and the denominator, cancel the thing that's causing it to equal 0, the numerator and the denominator, and then plug your number in and then get your answer for your limit. Okay? Let's try another one. All right, here's another limit. We've got the limit as x approaches negative 8 of x squared minus 64 over x plus 8. Again, if we plug the negative 8 in, we get 64 minus 64, 0. Negative 8 plus 8, also 0. So we got 0 over 0. So we're going to factor, cancel, and plug in. Well, the denominator is only one factor. So the numerator, x squared minus 64, well, that becomes, we'll have the limit as x approaches negative 8. The numerator factors into x plus 8 times x minus 8. Again, it's a difference of squares over x plus 8. The numerator, x plus 8, and the denominator, x plus 8, cancel. And now all we have left is x minus 8. We'll plug the negative 8 in for x, and negative 8 minus 8 is negative 16. And we're done. Negative 16. We factored, we canceled, and then we plugged in. Okay? Let's try another one. All right, this one isn't that much harder, but it is a little different. We don't have a difference of squares, but we still result in 0 over 0 if we were to plug the limiting value in. So if we plug 3 in, we get 9 minus 3 is 6, minus 6 is 0. In the denominator, 3 minus 3 is 0. 0 over 0. So we're going to go...
Corey Davis, please report to the front office.
So we're going to go to our 3 steps here: factor, then cancel, then plug in. Okay? Now, the denominator cannot be factored. The numerator can be factored. Now, here's the thing. Do you remember how to factor? Basic quadratic factoring when the lead coefficient is 1. So all we need to do is we need to look for what two numbers multiply to -6 but add up to -1. Now, even if you're not very good at this factoring, you still get a hint, because here's the thing. Do you know what you're going to be canceling? Well, you're going to be canceling whatever you see right here in the denominator. It's x minus 3. There has to be an x minus 3 in here. So you know one of your factors is x minus 3. So we know that this -6 is being multiplied by -3. Okay? So what times -3 is equal to -6? Well, it's positive 2, right? So positive 2 times -3 is -6. And positive 2 plus -3 is equal to -1. So we know that our factors are x plus 2 and x minus 3. And the denominator is x minus 3. And this is still the limit as x approaches 3, right? So step 1, we factored. Now we're going to cancel the x minus 3's. Step 3, plug in. So we're going to plug the 3 in for the x. 3 plus 2 is 5. So our answer is 5. Okay? Let's try another one. All right, here's another limit. Only this one's a little bit different. It's not that much different, but it's a little bit different. Okay? Here now we've got the x minus 9 is in the numerator and the quadratic is in the denominator. Not that big of a deal. It's still the same procedure. Okay? If we put the 9 in here, 9 minus 9 is 0. Put the 9 in here, 9 squared is 81. 14 times 9 is, what do we got here? 9 is 30, it's 126, right? So 81 minus, oh gosh, this is... So 9 minus 9, that's 0, right? Now, plug the 9 in here, and we get 9 squared minus 14 times 9 plus 45. Let's grab a calculator. Let's do 9 squared minus 14 times 9 plus 45, and we get 0. Sure enough. Okay, so we got 0 over 0. And so we need to factor, then cancel, then plug in. So we're going to factor the denominator here because the numerator can't be factored. Well, we know that the thing that's making the denominator equal 0 is x minus 9, okay? So one of the factors is x minus 9. So what does -9 have to be multiplied by to equal positive 45? It's got to be multiplied by -5, right? -9 times -5 is positive 45. -9 plus -5 is -14. So this denominator factors into x minus 5 times x minus 9. And the numerator is still x minus 9. And this is still a limit as x approaches 9. Okay? Step 1, we factored. Now we're going to cancel. Cancel the x minus 9's. And all we have left is an x minus 5, right? Now, what's left in the numerator? Some people get confused here. Some people, when they cancel it, some students think, oh well, there's nothing there now, so it must be a 0. No, we canceled by division, right? And x minus 9 divided by x minus 9, that's 1. So there's a 1 in the numerator, okay? There's a 1 there, okay? So now it's going to be 1 over x minus 5. When we plug the 9 in, 9 minus 5, well, that's 4, so our answer is going to be 1 over 4, and that's our answer. The answer to this limit is 1/4, okay? Got to try another one. All right, here's another one, and aren't these getting really fun? I know. So now we got a quadratic in the numerator and the denominator. Okay, so what we're going to have to do is, if it results in 0 over 0, which it does, if you want to go ahead and pause it and try it, it's a 0 over 0. We plug that negative 5 in, we get 0 over 0. So that's an x and 9. Okay, but we have a quadratic in the numerator and the denominator, so what we need to do now is we need to factor the numerator, factor the denominator, then cancel, then plug in. Okay? So we know with this negative 5, we know that the factor must be x plus 5, okay? Because negative 5 plus 5 equals 0. So our factor, by the factor theorem, there must be an x plus 5 in here, and there must be an x plus 5 in here. So let's go ahead and factor them out. So if we're looking for two numbers that multiply to negative 15, and one of them is positive 5, the other one has to be negative 3. So we've got an x plus 5 and an x minus 3. So we've got an x minus 3 times x plus 5 over. Down here, again, there has to be an x plus 5 in there. Well, what's going to go along with a positive 5 to get a positive 20? Must be a positive 4. Positive 4 times positive 5 is positive 20. So our other factor is x plus 4. So this factors into x plus 4 times x plus 5, right? I'm going to close that off. And when it's still a limit, it's the limit as x approaches negative 5. And now we can cancel the numerator and the denominator, cancel x plus 5 in the numerator and the denominator. And now all we have left is x minus 3 over x plus 4. And so now we're going to plug negative 5 in. Negative 5 minus 3 is negative 8 over negative 5 plus 4 is negative 1. So we have negative 8 over negative 1, which is positive 8, and that is the answer to this limit. Okay? Let's just do a couple more. All right, now this is the kind of limit problem that your teacher would give you to just kind of throw you unexpectedly, because it's super easy, but you're not expecting it, so you think it's super hard, and you're looking for something where you're factoring this quadratic, but this one's so easy that what you're accustomed to doing to the little more difficult ones doesn't work, okay? But this one's actually really, really easy. This is easier than the other ones we've done. We know that if we plug 0 in, this becomes 0 and this becomes 0. 0 plus 0 is 0. This becomes 0 and this becomes 0, and 0 minus 0 is 0. So we have 0 over 0. So we're going to factor, right? Okay, but the thing is, this is easier to factor than the other ones, because look, all you have to do is take out a greatest common factor. All you have to do is factor an x out of here and here, leaving you with x times 7x plus 18 over, and you can factor an x out of the bottom. X times 5x minus 3. It's a limit. The limit, I got to squeeze this limit in here, equals the limit as x approaches 0, right? So now, check this out. We factored, now we're going to cancel. But we're not canceling the binomials, we're canceling the x. These x's, those are going to cancel out. Now all you have left is 7x plus 18 and 5x minus 3. Now if I plug the 0 in, 7 times 0 is 0. And 0 plus 18, well, that's 18. Now I'm going to plug the 0 in down here. 5 times 0, that's 0. Minus 3 is negative 3. So I have 18 over negative 3, and 18 divided by negative 3 is negative 6. So my limit is negative 6. All right, we just have a couple more that we're going to try, okay? This one is going to require synthetic division. Well, technically it doesn't require synthetic division, but because this numerator is a third power polynomial, synthetic division is going to make it a lot easier to deal with than some other techniques. Now, if you have a graphing calculator, you could figure it out. That'll help out. But we're not going to use a graphing calculator. We're doing this analytically all the way. Okay, so here's the deal. This denominator is quadratic, so it can be factored normally, okay, using quadratic factoring. Just so you know, go ahead and plug the 2 in, and you'll get 0 over 0. Okay, so once you have your 0 over 0, you'll see that now we need to factor down the numerator and factor down the denominator so that we can cancel something out. What is it, though, that we're going to cancel out? Think about that for a minute. If positive 2 is what's causing the numerator and the denominator to equal 0, then what binomial factor is causing the numerator and denominator to equal 0? Well, if the number that's making it equal 0, is 2, then it must be x minus 2. It must be the factor x minus 2 that is causing the numerator and the denominator to equal 0, because 2 minus 2 equals 0. So all we have to do is use some kind of polynomial division to divide out x minus 2, and then we will have and then they'll be factored out, and then we can cancel the x minus 2's. Now the denominator is much easier. The denominator is quadratic, so we can just factor out the x minus 2. So if we have a plus 12 here at the end, if we know that negative 2 is being multiplied by something to get positive 12, we know that that number must be negative 6, because negative 6 times negative 2 is positive 12. So our two factors for the denominator are x minus 2 and x minus 6. Okay, so let's go ahead and write, we've got the limit as x approaches 2 of, our denominator is going to be x minus 6 times x minus 2. Okay, I'll leave some space in the numerator here. And now, why use polynomial long division to divide this numerator here by x minus 2 when this meets the requirements of synthetic division? So what we're going to do here is we're just going to put our 2 here in the half box. Now, this is also related, if you know the remainder theorem. This is related to the remainder theorem, because the remainder theorem says that if you use some kind of polynomial division, whatever number you plugged in or whatever you divided by, right, this x minus 2, whatever would cause that to equal 0, if you're plugging that in here in the half box, your answer is going to be whatever you would get in the polynomial if you had plugged that number in. So we should be getting a remainder of 0, because plugging 2 in here gives us 0. Okay? Now with synthetic division, we don't need all these x's, we just need the coefficients. The coefficient of x cubed is 1, so we're going to put a 1 here. Coefficient here is 3. Then we got a negative 12. Then we've got a positive 4. I'm going to draw the line here. Okay? Now, your way of doing synthetic division is a little different than mine, but I'm going to do it your way. But typically, I'll put a 0 here and then add. But the way you understand it usually is you just carry the 1 down, right? Okay? So we'll carry the 1 down, or we could just put a 0 here and add. 1 plus 0 is 1. Okay? Then we multiply this number by 2. 2 times 1 is 2, and we put it under the next number. Then we add up and down. 3 plus 2 is 5. 5 times 2 is 10. 10 plus negative 12 is negative 2. And negative 2 times 2 is negative 4. And you guessed it, 4 plus negative 4 is 0. So we have a remainder of 0, just like I said we would. Okay? So now, these three numbers are the coefficients of our quotient. Okay? We started off with x to the third power, and when we use synthetic division, our answer always goes, the power goes down by 1. So if this is x to the third power, our quotient is going to be x to the second power. So this is x to the second power, right? That's x to the second power, and this is x to the first power, and this one doesn't get an x because it's x to the 0 power. So 1x squared is just x squared. This is a positive 5, so that's plus 5x. Then we have a minus 2. And what that means is that when we divide out x minus 2, we get x squared plus 5x minus 2. And that means that this and this are factors. We have factored this larger polynomial into x squared plus 5x minus 2 times x minus 2. So we have factored the numerator, we have factored the denominator. Now we can cancel and then plug in. So we're going to cancel the x minus 2's, and now we're going to plug 2 into the numerator and the denominator. So I'm going to use a different color here. If we plug 2 in here, 2 squared is 4, plus 5 times 2, that's 10 minus 2. In the denominator, 2 minus 6, that's negative 4. All right? So what we have here is a numerator, 4 plus 10, that's 14, minus 2, that's 12. So we have 12 over negative 4, and 12 divided by negative 4 is negative 3. So the limit, as x approaches 2 of this mess, is negative 3. We're going to do one more example, and then we're going to call it quits. All right, here's our last limit. And isn't that a ridiculous beauty, right? I mean, I know it's ridiculous. Come on. But the only reason I made this enormous rational function is just to show you that it doesn't matter how large the polynomial is. If you result in 0 over 0, you can use synthetic division, factoring, in order to solve the limit. Okay? So here we go. If you can pause the video, plug your negative 1 in, you're going to get 0 over 0. Okay? So now, because they're not kind of simple polynomials, we've got lead coefficients that aren't 1. They're kind of messy. And I know that if these numbers were all fractions and other weird stuff, you could still use synthetic division, but boy, would it be very, very messy. But it'll still work. If you are patient and you are determined, you will get through and you will find the limit. Okay? So here's what I want to show you is we got this 0 over 0 when we plug in negative 1. So what I'm suggesting is we can do synthetic division in the numerator and synthetic division in the denominator, and that will factor out the factor we're concerned with. And the factor we're concerned with, if we're plugging in negative 1, then what binomial factor is associated with an x of negative 1? Well, it's x plus 1, right? All right, so the factor we're concerned about here, the one that we know is in there somewhere, is x plus 1. So we're going to divide an x plus 1 out of the numerator. Then we're going to divide an x plus 1 out of the denominator. And then we're going to cancel the x plus 1's, and we're going to plug the negative 1 in. So we're going to put negative 1 in the half box. We're going to use our coefficients here, 5, then negative 2, then negative 9, then 2, and then 4. I'm going to put a 0 here, and then 5 plus 0 is 5. 5 times negative 1 is negative 5, minus 2 is negative 7. Negative 7 times negative 1 is positive 7, minus 9 is negative 2. Negative 2 times negative 1 is positive 2. 2 plus 2 is 4, and 4 times negative 1 is negative 4. 4 minus 4 is 0, remainder of 0, just like I expected we would have. Since the degree or the highest power of this polynomial is 4, we know that this one is going to have the highest power of 3. So it's going to be 5x to the third minus 7x squared minus 2x plus 4. Okay? So what we're going to have here is this is now going to be the limit as x approaches negative 1 of the numerator is going to be 5x to the third minus 7x squared minus 2x plus 4 times x plus 1, right? We just factored x plus 1 out of the numerator. Now we're going to do it to the denominator. So again, let's see here. We're going to do our negative 1 in the half box. We got a 9. We've got a 5, we've got a negative 7, we've got a 3, and then a 6. Draw our line. I'll put a 0 under the 9. 9 plus 0 is 9. 9 times negative 1 is negative 9, plus 5 is negative 4. Negative 4 times negative 1 is positive 4, minus 7 is negative 3. Negative 3 times negative 1 is 3, and 3 plus 3 is 6. 6 times negative 1 is negative 6, plus 6 is 0. Again, remainder of 0 as expected. So now, this was 9x to the fourth, so now this is going to become 9x to the third power, right? So here we go, 9x to the third power minus 4x squared, minus 3x plus 6 times the factor that we divided out, x plus 1. So we completed step 1, factor. So we factored the numerator, factored the denominator, not necessarily completely, but all we had to factor out was the x plus 1. So now we can cancel the x plus 1, and now we can plug negative 1 in for x in the numerator and the denominator, and we can find out what our answer is. Now, something interesting could happen here. If we wind up with 0 over 0 again, that means that there is another x plus 1 in the numerator and another x plus 1 in the denominator, and you would have to use synthetic division to take them out again. I'm not going to do that to y'all, my students, at least not right now, but that could happen in a problem, okay? So here, at least I think I'm not going to do it to you. So I'm going to put the negative 1 in here, and negative 1 to the third power is negative 1, and negative 1 times 5 is negative 5. Negative 1 in here, negative 1 squared, negative 1 times negative 1 is positive 1. Positive 1 times negative 7 is negative 7. Negative 1 times negative 2 is positive 2, and now we have a plus 4 on here at the end. In this denominator here, negative 1 plugged in here, negative 1 to the third power is negative 1. Negative 1 times 9 is negative 9. Negative 1 squared is positive 1 times negative 4 is negative 4. Negative 1 times negative 3 is positive 3. And then we have a plus 6 on here at the end. Okay? Pardon me. All right. Now we can find the answer. So our numerator winds up being negative 5 minus 7, that's negative 12. Plus 2, that's it's negative 10. Plus 4, that's negative 6. Okay? Then, we got negative 9 minus 4, that's negative 13. Plus 3 is negative 10. Plus 6 is negative 4. And so we have negative 6 over negative 4. We can reduce that. A negative divided by a negative is a positive. 6 over 4 is the same thing as 3 over 2. So the limit, as x approaches negative 1 of this mess right here, final answer, 3 over 2. And that is, well, one strategy. When you're dealing with polynomials in the numerator and the denominator, you always come up with 0 over 0. If all those circumstances exist, then you can use this strategy right here. And if they're very difficult polynomials in the numerator and or denominator, then you can use synthetic division instead of the easy kind of factoring.